Okay, so we are told a tennis class has 9 students, of which 2 are aged 13, 3 are aged 14, and 4 are aged 15. The coach chooses 2 students at random to form a doubles team. We want to find, first of all, the probability that both the students are of the same age. So, we are finding probability, same age. What we need to do to answer this question is consider all the different possible ways that students could be chosen so that they are the same age. So we can have either probability, we have 2 13-year-olds, or 2 14-year-olds, or 2 15-year-olds. Okay, so this would then actually, because I'm doing probability of 2 13-year-olds or 2 14-year-olds or 2 15-year-olds, this is going to be equal to the probability of 2 13-year-olds plus the probability of 2 14-year-olds plus the probability of 2 15-year-olds. So remember, when we're looking for one event or another event happening when we're working with combinations, that we add up the different ways. So let's do the probability of 2 14-year-olds. So what we're looking at here is we have, we start with 14-year-olds. We have 3 aged 14, so we're going to have 3, and we are going to choose 2 of those 3. So total number of ways we can pick 2 14-year-olds is 3, choose 2. Total number of ways we can pick 2 people from the number of students is there are 9 students, and we are choosing 2. Okay, so when I put this into my calculator, what we get out is a value of 1/12. And remember, just leave it as a fraction, don't write it as a decimal. This is an exact representation. Okay, so I can do the probability of 2 13-year-olds. Okay, so there are 2 13-year-olds, and I am going to choose 2 13-year-olds, and this is all over 9 potential students, choose 2. When I work through this on my calculator, I get a probability of 1/36. Okay, so then probability of choosing 2 15-year-olds, very, very similar to what we've done before. This time I've got 4 age 15, so it's going to be 4, choose 2. It's the number of ways I can pick the 2 15-year-olds over the total number of ways I can pick 2 students from 9. So when I put this through and work through this on my calculator, it is 1/6. So finally, having worked out all those individual probabilities, probability that we have the same age, well, this is given by adding up 1/36 plus 1/12 plus 1/6. And so use your calculator just to make sure we're not making any silly mistakes. We should be able to do the fractions anyway, but let's not take any chances because it's an exam. I get probability of 5/18. Okay, so how do we get the marks on this question? Well, you need to think about how this is going to happen first of all, but actually your marks are given as a statement mark for identifying how to calculate the probability of getting 2 14-year-olds, statement mark for identifying how to get the probability for 2 13-year-olds, statement mark for identifying how to get the probability for getting 2 15-year-olds, and then finally a statement mark at the end for getting our final probability of 5/18. Okay. If for whatever reason you haven't actually calculated these probabilities, you put it perhaps all into this formula here, you get the statement marks for actually the methods here. However, at the end you have to get the 5/18 to get the statement mark at the end. Okay, so let's have a look at part B. Part B says, hence or otherwise calculate the probability that the students are different ages. Okay, so probability, different ages. Well, actually, there are only two choices if you think about this a certain way. I mean, you could try and work out all the combinations of having different ages, but actually all we want to think about here is you can either pick the team so they're both the same age, or they're not the same age. So probability of different ages is simply then 1 minus the probability that they are the same age. Just to simplify it perhaps a little bit, if you want, you could think about this as probability of rolling a 6 or probability of not rolling a 6. So 1 minus the probability of rolling 6. So here we have 1 minus probability of being the same age, so I get 1 minus 5 over 18. So this gives us a probability of 13 over 18. Okay, so how do we get our marks on this question? Well, first of all, we can have a method mark for identifying 1 minus the probability of the same age, and then we can have an accuracy mark for actually calculating that it's 13 over 18. Okay, so I hope that made sense and that you understood it.